each and every one in detail. But the famous one is also known as the Log4 shell. So we will discuss about that. Okay. So it has been more than a month. We are reading, we are listening, we are talking about Log4j vulnerabilities. It was and somewhat it is almost everywhere on Twitter, on blogs, on YouTube, on news articles, and in the headlines of few giant publication houses as well. Would you believe it? A short and sweet and such a simple vulnerability received so much boom in whole world. So what is this log4j vulnerability? Why it happened? Especially the booming log4 shell vulnerability. What is the page available to log4 shell? The vulnerability discovered in the proposed patch, and finally the mitigation that needs to applied till today's date. So, here the first one is the very famous one, Log4 shell, and we will discuss rest two as well. And we will discuss mitigation for each one by one. But the final at the end, we will discuss the exact mitigation you need to implement in your application as per today's date. So let's begin. What is Log4j? So you probably already know what is Log4j. It's a very popular and one of the widely used logging library for Java-based applications. It's an open source utility provided by Apache Software Foundation. Okay, so the Log4j library is from the application code, so it can log things to a file whenever that, or maybe some other user information, like the request was received from this user agent, or maybe this IP, so this kind of user information, or maybe I think the list is endless, right? So the logging, I mean the possibilities of the logging varies business to business based on their requirements. For example, if for someone the user agent and the user information is very critical part of their analytics, while for some it's useless. So it varies business to business. Okay, and this logs stored in the file will be later used by the IT team of the company, of the organization, for maybe troubleshooting the problems they are facing on the application, or maybe understand the mistakes they have done in the code from the stack trace or from the exceptions, or maybe to understand the attacks happen on the application, so they can get an idea of the like how attack was happened, right? So a pretty typical stuff in general, I would say. As I said earlier, like Log4j, which is one of the most popular and widely used logging library, is being doing its job pretty well till now, till December, I would say. So from years now, yeah, it was doing really good. However, there was a dark, deep secret which was hidden under the surface of the Log4j, like a treasure of the lost city, hidden somewhere. Let's keep the movie thing aside. So a major security vulnerability that's now come into the open, and it was like, oh my god, we have a big issue in our hands. Any Java application that uses Log4j can be hacked. That is anything lower than the recently patched version of the Log4j, which is 2.17.1, as of the date of this webinar, right? Yeah, you heard it right, man. 2.17.1 is the latest one. Some of you might be following this topic since the beginning, but some of you might say, wait a minute, 2.16 was the patch, or is the page for Log4Shell? My dear friends, you are absolutely right. That was the patch, but the story of the Log4j was not till that only. Okay, the story of the Log4j utility or the library is now having additional chapters as well. And who knows, maybe we have more chapter could be added to the Log4j story, or maybe not, right? So after the Log4j vulnerability information came into the public, right? It came into the on the internet. There was and there is a race between companies and the hackers. On one side, the companies, in a very technical term, I would say blue team, are patching the vulnerabilities, and on the other hand, the I mean hackers, right, with bad intention or maybe some good intention as well, like us, are racing to exploit the vulnerability in the target application before it get patched properly by the targets, right? It's fun, isn't it? I must mention that we at Secure 7 have seen and experienced the real action of the exploitation and the patching of Log4j vulnerability, right? Lots and lots of stuff was going on, but we are committed for the security of our customers with our motto, time and against securing you. So we were, continually checking out the Log4j vulnerability in all of our client applications, and we were trying to make it secure before a hacker get, exploit that vulnerability in the our customers' applications. So many of the application frameworks, for example, the Java developed, many of the application frameworks which are developed in Java, for example, the Apache Struts, Solar, Druid, Spring, maybe Spring Boot, and multiple others, right? So they are using the Log4j by default. You might be thinking like that you have a Java based application, okay, but you are not using Log4j, so you are good. Wait a minute, guys. According to statistics of the sync, around more than 60% of the Java projects are using Log4j utility indirectly, and less than 40% of the projects uses it directly, right? So if you are thinking like I'm not using Log4j, so I'm good, I don't have to worry about it. So you might be using some other libraries in the application which is using the Log4j, or maybe you are using some other library in your application which is using some other library in your in that utility, and that library, that hierarchy, is using a Log4j. So somewhere on any level of the hierarchy, Log4j utility could have been used. So the probability is really high that the Log4j is used in the application here or somewhere. Okay, so we have a good context of it. So let's move on to the very first bug came into the public, which is also famous as Log4 shell, right? So the Log4 shell is a critical severity vulnerability with CVSS score 10. Okay, so the so the CVSS score 10 is out of 10, so it's a maximum, right? So the multiple versions of the Apache Log4j2 utility are affected from version 2.0 to 2.14.1, and as per the sources, like the vulnerability was disclosed by Chen Chao Jun, I'm sorry for the pronunciation, of the Alibaba Cloud Security team on December 9. Okay, so the CVSS score stands for Common Vulnerability Scoring System, and the 10, it's the highest that could be possible, right? So it is the worst scenario for the project owner or for the target application which are using the Log4j, and it is a very good scenario for the hackers to exploit it. Okay, so okay, now this vulnerability could allow an attacker for an unauthenticated RCE, remote code execution, right? But now, why is that? Why is that the reason for this, that this vulnerability enables what referred to as RCE? Okay, so it allows a hackers to be able to run any code on the machine by hacking into the application which uses a Log4j. Alright, so this, they can run any code they want. They can do multiple stuff when they have the code execution remotely, right? They can fetch the information available on your server, they can dump all the data available on the server, they can redirect the application users to somewhat malicious article controllable websites. They can affect the availability, they can affect the confidentiality, and they can affect the integrity of the application itself, right, when we have the RC. So let's understand like what exactly this vulnerability is, right? So there are, I believe, two or three components which are very necessary, which makes this vulnerability exploitable. Okay. However, these components in themselves are not vulnerable. It might be seems confusing from my words, but don't worry, we will discuss each and everything, and you will have a clarity of the same. Okay. So the log4j uses, logs expressions, right? What I mean by expressions. The log4j, if you see in this code snippet, on the first line it creates a object of the log manager. Then there is a try catch, there is a try and catch, and in the try we are evaluating the item. Think of any item, like whether it's an integer or not, or whether it's a valid item or not. So there is just an evaluation of the same with that method. And in the catch part, if the evaluation got failed and we have some sort of exception, right, so that we are logging into the file with the logger.error message, okay, that failed to evaluate item and the item value, right? So it's a very simple thing, right? Whatever you are submitting there is being logged, right? So pretty normal stuff like all the loggers are doing, nothing special here. Next thing is like, JNDI. So the JNDI stands for Java Naming and Directory interface, right? So what does this JNDI do? JNDI allows you to store the Java object in any remote location and then serialize them, a kind of a streaming them into your GVM. So it was introduced a long ago, like a pre-REST API era, I believe, but it's still present in the modern day because of the backward compatibility of the previous versions for the previous versions of the Java. If you might be aware, like Java is not deprecating anything. So JNDI was introduced a long ago, but it's still working till in the modern era. So it basically, whatever you have the Java code or Java object written somewhere on the remote location, and you can just get the path of that Java object, and that object will be serialized and will be running into your JVM, right? So that's a simple fundamental of the JNDI. So here with the code snippet, if you see the with the LDAP and article controllable website.com and some path from there, from this particular URL, an attacker or we can serialize any object from there, right? These both components are not vulnerable in themselves, but when they are merged together, the log4j expressions and the JNDI, it creates a log4 shell. Now you might be wondering like how this could be possible, right? I will explain why. So in, I believe in around 2013, the Log4j library have introduced to use the JNDI in the logging expressions, right? With that, it was just a normal functionality of Java, right? JNDI. And here, if you see in the code snippet, first we have in the on the first line we have defined the logger object. Then we are evaluating the item, and if some exception came, there are two curly braces, right? One, these are for the parameters which we are passing into that particular logger error. So here we are giving the curly braces for the prefix, and at the end this curly braces are for the next item, right? So the prefix is being fetched from the with the use of JNDI from a remote location. So you might be thinking like, why the prefix is needed from a remote location? So there are multiple scenarios where this is really useful. For example, you have a system developed, right, which you are using for your multiple customers, and you want to give a prefix separately for each and every customer, right? So instead of hard coding it somewhere here and there, you can simply, make a object somewhere on your location and have that as a prefix in the logger, right? So that's a very basic idea I can give you about this, right? So this JNDI will look up for this particular URL, okay, which was provided. It will try to look up over there and get a serialized object, run it in the JVM, and put the value in the first curly braces, right? Yeah, and the second one is for the item. Now think like, you or we as an attacker, we are giving a RC code to the application for logging, right? And once the JNDI resolve that particular object and run it into the JVM, we have the remote code execution on our hand, right? So as I said in the previous slide, this both component log4j and JNDI are not vulnerable in themselves, but when they are merged together into the log4j, at that time the log4 shall happen, right? So I hope you get a much clarity, like, what exactly this vulnerability is and why it occurs, okay? So we will discuss a mitigation for this log4 shell vulnerability, okay? So the very first thing is, like, you can off the flags this both jndi.ldap.object.trust.url code base and jndi.rmi. So when you set these flags to off, and someone just enter any jndi lookup URL, your JVM will think like, okay, I have a JNDI request. I have the LDAP or remote method invocation request. But wait a minute, I don't trust that URL, right? So that's the very basic thing you can do first. The mitigation which was proposed for this log4 shell vulnerability was, upgrading to the newer version of the log4j, which is 2.15. And for some of the companies or some of the application, it was not directly possible to completely upgrade the log4j library. There might be some sort of dependency, there might be some sort of issues they are facing, due to which they are not able to upgrade to the latest version, or maybe they are using some third-party library which is using log4j in that, and they are not upgrading it, or the patch is not available, or maybe they will never gonna patch it. So in that case, the class file is directly being patched with the newer class file in the used log4j. And for the Java based application, the Gradle uses a dependency constraint, so you can you can strictly use the latest version itself, right? So this was the mitigation proposed for log4 shell, but my dear friends, don't go for 2.15, right? As I say it, like, the story have more chapters. So let's move on to the next chapter, right? It's a CV 2021 45046, right? So the patch which was previously addressing the log4 shell was incomplete, I would say, like, with the non-default configuration. So the attack scenario was a bit different, but the outcome of this particular vulnerability was almost the same. It was causing the sensitive information disclosure and can lead to the remote code execution again, right? So it was like, found like, the previous CV 44 2010 22.8, right? The log4 share was incomplete in certain non-default configuration. So the attacker were allowed to control over the MDC, like thread context map, Input the data when the logging configuration uses a non-default pattern, the layout with either context lookup or maybe a thread context map pattern. So because of that, they can craft a malicious input data using the JNDI lookup pattern and resulting into the same either information disclosure or maybe RC, right? So okay, we got an idea, like the patch was not proper, and because of that, again, we were able to do the RC. We were able to remotely execute the code. Okay, so what's the mitigation for that? So pretty much the mitigation is the same in general, but the Log4j team have released a newer version, which is 2.16.0. Here is the typo mistake, please pardon me for that. For Java 8 and 2.12.2 for Java 7, right? The same resting are the same, like fetch the class directly from this version and set this off and the Gradle dependency, right? But here also the story is not yet completed, right? After the patch proposed in 2.16.0, we have a new vulnerability found in the 2.16.0, right? And the CV assigned to it was 45105, right? So here the patch applied to the previous vulnerability for 4228 and 45046 in the Apache Log4j version was allowing an attacker to use an uncontrolled recursion, right, from the self-referential lookups. What I mean by this is, like we are injecting some sort of payload which is referencing back to the lookup itself, right? So the Apache log4 I mean yeah, so the Apache Log4j2 version, right, from 2.0 alpha 1 to the 2.16.0 did not protect the uncontrolled recursion from the self-referential lookup, right? So this allows an attacker with a control over the thread context map data to cause a DOS attack, right? Now, the issue over here is not an RC, but it is a denial of service attack. So in the first one, the 44.22.8, the attacker have patched the vulnerability by disabling the JNDI and some other configuration, but it was again able to attacker were able to execute the RC, and we have a next vulnerability which is 45046. After that, the attacker have tried to completely, patch that vulnerability again, and at the end, the attacker have, the Log4j team, I'm sorry, have decided to completely remove the support for JNDI, right? And the final mitigation which you need to do till this date, right, is to set this flags off, upgrade to the newer version of the log4j, which is 2. And strictly use the dependency constraint in the Gradle, right? But here the question comes, like what if I am just setting this flags off? Wouldn't it resolve my problem? Yeah, it mostly resolve your problem, but there is a one scenario where you have to where the data might get leaked or where the information might get leaked to the attacker, right? So what is that scenario? In that scenario is like you are blocking the request with the JNDI URL, okay? If there is a LDAP or if there is a JNDI in use, so you are blocking the request coming to your target, right? You are not trusting that URL. But what if a target, if an attacker try to fetch your environment variable, okay, with the help of JNDI? So it could be like LDAP colon JNDI, and the payload would be like the attacker.com slash dollar environment variable AWS key, for example, or maybe some sensitive other environment key, and they are sending a request. So actually the JVM is not gonna trust that URL, right? But the information will pass from your server to the attacker's machine, right? So setting this flags off will not properly patch your vulnerability. You have to upgrade it to the latest version, patch the class directly either, right? So that's the exact mitigation you have to do till the date. With that note, like I would like to see, like, are you, I mean, I hope you got the complete idea of the Log4j vulnerabilities, right? What is the Log4 shell, then what happened to that mitigation, and then what is the exit page you need to make till now. And if there will be any, further, if the story continues, I will definitely get back to you with new updates on the same, right? So that's pretty much all, right? But we have, yeah, if you have any question, you can feel free to ask me. But before that, I would like to, mention one question to you, all of you guys. Like, it is a very important thing. The vulnerability, such as the Log4 shell and others, right, will come and will go, right? This will likely get patched, all these vulnerabilities. People will move on, the life will go on like a normal, and everything will be normal pretty much in some time. But this, make me thinking about the open source in general. We are thinking open source utilities as a more secure. Why? Because it's a open source, so everyone knows the code, everyone is having an eye on the code, and because of that, if there is any security issue, it could be identified on upfront only. No, this vulnerability was, the feature which make this log4j vulnerable was introduced in 2013, right? Until now it was there in the wild and no one was aware, right? So it might be happen the other open source utilities or the libraries could also have some sort of vulnerabilities which is there, right? And we don't know about it. Or maybe it could happen someone